Hello, everybody. For today's lesson, we had first gone to Canvas and clicked on the link that said inverse functions, exponents, and logarithms. It is a Desmos activity. It is very guided. Please go through it because it kind of leads us to what we are talking about right now. So it would be a very good idea, and you will get a deeper understanding if you do this. But basically, we're talking about the inverse of exponential functions, so the opposite. The inverse of an exponential function is a logarithmic function. So if I have this exponential shape, the blue graph, y equals 2 to the x, where x is in the exponent, the inverse is this red graph, this logarithmic graph. And in the equation, I see the word log in it. So log for logarithmic. And I see that instead of starting from kind of like flat on the x-axis and then shooting up forever, it is starting from the y-axis and then it's coming up and it's not going like too fast up, but it is going pretty sharply to the right. So it's kind of the opposite. So instead of having a horizontal asymptote here, so a side-to-side asymptote here, the logarithmic function has a vertical one. So please sketch these as accurately as possible and label them. Okay, so label the blue one as y equals 2 to the x, label the logarithmic, the red function, as y equals log base 2 of x. In this video, we'll mainly be focusing on converting between exponential and logarithmic equations. This other stuff we'll be covering in a different video because we did split this lesson up into 2 days. So converting between exponential functions and logarithmic functions. It's a formula, so we can start with an exponential, meaning that we have an exponent, and we can change it to a logarithm. So we would have log, all right, the b would be down here now. And notice that a and x switch sides. So b stands for base. It's supposed to say argument, and then x is for exponent. So whereas in an exponential, the exponent is up at top, in a logarithm, it's going to tell you what the exponent should be. Okay, so if you're given a base and an argument, it's like saying, okay, what does the power on this base need to be to give me this number right here? That's what a logarithm is telling me. So let's look at some examples. So we are going to start out here. Okay, we need to be able to identify our base. So this is B, our base, and I'm going to color code base. And this is our exponent. And this one is our argument. It's typing it kind of disgustingly. Argument is what that's supposed to say. So when I'm rewriting it in my log format, I should have log, the base at the bottom, then the argument is next, and then it equals whatever my exponent is. Bro. Okay, so please forgive the weird stuff, but that is log base 10 of 100 equals 2. All right, so you can try out the other ones on your own. All right, I am very quickly going to do them off screen. So I think it switched screens at the last minute there, but this is what these answers look like. So notice that b, our base, like here it's 3, always stays on the bottom. Here it's 5, it stays on the bottom. Then my argument in x, where they're at, like which side of the equal sign they're on, it switches. So 81 should be over here now with the log, and then the exponent should be on the other side. Here the 1 is with the log, the exponent should be on the other side. Moving on, if we see something like this, the idea is the same, we just have to go backwards. So if I'm looking from this, I know my number on the bottom, like here it's 3, that is B. I know that over here, this is A. And then I do know that here, it keeps crossing them out. I don't mean for it to do that. This is X. So when I'm writing, I've got 3 with an exponent of 2 equals 9. And that makes sense. 3 squared, or 3 times 3, equals 9. So you can try out the other ones on your own just the same. I am going to work them out off screen so that you can see. So you can check quickly. You can check yourself here, but again, same thing. Notice that our number on the bottom of the log is our number on the bottom of the exponent. So you can think B for base, for bottom, because it's our number on the bottom. 3 goes here and here, 4 is on the bottom and then it's on the bottom, 5 is on the bottom and then it's on the bottom. And then of course, again, the argument and the exponent switch what side they're on. So now where the exponent was on the other side of the equal sign from the log, now it is back in the exponent. And our argument is our answer on the other side of the equal sign. Let's go on to the last set of problems. So here, what's different about this one from these problems, is that these ones had an equal sign. These do not have an equal sign. So really what this is asking us, it's giving us the base and it's giving us the argument, right? So it's giving us, it's giving us the base, it's giving us the argument. What we need is the exponent. So what it is asking us, 5 to what power is going to give us 125? Right, so we can use a calculator to help us out here, and I will show you how. Here, when I'm using Desmos to help me figure out what power 5 has to be to give me 105, I can just click 5 and do the little exponent button and change that number on top until it gives me 125. So if I make it 1, that equals 5. So the exponent is not 1. 2, it is 25, but not 125. Then when I put an exponent of 3, it gives me 125. So my answer is 3. So when I go back and I'm writing down my answer, I know that since 5 to the 3 is 125, that means that 3 is my answer. That x equals 3. So that is my answer. So you can try this out with the other problems. So I will give you can pause the video to see what you can do on your own, but then I will have the answers here. So here I haven't quite given the answers, just the setup, right? But In all of these problems, it is the same. They give us the base, they give us the argument, we need to figure out the exponent. So yet again, we can go to Desmos to figure that out. So for the second problem, 8 raised to what power is going to give us 512? And so we can try out different powers. All right, 0 is not the exponent for us. 1 is not it. Neither is 2. 3 is our exponent. So for the second problem, x equals 3. Now, for the third problem, I want to see what exponent is going to give me 1 over 27. When I start from 1, immediately I have a whole number. And every time I make my exponent bigger, my number that it equals is going to get bigger. So obviously this isn't working out. And when I want to get smaller, let's say I go to 0, it just gives me that it equals 1. Well, if I've tried out 0, and even if I try out fractions or decimals as exponents, it doesn't work. It doesn't make it smaller. Okay, if I've tried out numbers that are bigger than 0, and that doesn't work, then I need to go the opposite direction. I need to try numbers that are smaller than 0. So making the exponent negative is going to give me a fraction. So see, now when I do 3 to the negative 1, that gives me 1 over 3. So I try out different negative numbers. Negative 2 gives me 1 over 9, and then negative 3 gives me 1 over 27. So when I go back to what my answers should be, I know that for this first problem, or for the second problem, 8 to the third power gives me 512. So x equals 3. And then for this problem, 3 to the negative 3 gives me 1 over 27. So my answer should be that x equals negative 3. Okay, so we're going to pick up on the same page in your notes, but it's going to be where this graph is. So this is where we are going to pick up next lesson. Bye.